So we are looking at this is the second part of trigonometry. We already did the first part. So we are only concentrating on special angles. We'll talk about half angles and double angles. That would be basically it. Okay. So let's get started. The first thing that we need to know about special angles is first thing first. We need to know the one equation that gives us all other special angles that we talk about. So it all starts from a Cartesian plane. So here is the x-axis and there is the y-axis. Okay, so when we are talking about these special angles, what you want to do is what we want to get one point. Let's say, for example, we have got a point at here. So we always want to connect that point to 0, comma 0. So you are going to move like this. And then I can just make a triangle, bring it down to the x-axis. So can you see we've made a triangle. This side that is parallel to the y-axis, let's call it y. The side x-axis, let's call it x, or the one which is along the x-axis. Every time you're talking about these angles, what you need to know about the hypotenuse is that the hypotenuse is going to be a resultant of x and y. So let me just call this as r, resultant. The angle that the resultant makes with the x-axis, this is called the direction. Okay? Like that. So this simple thing here is what we want to understand. So from it, let's use the Pythagoras theorem. We know that from the Pythagoras theorem, if you get x, you square it, and then plus you get y, you square it, it's going to give you the resultant squared. Remember, two sides, if you square them and then you add it, to give you the square of the hypotenuse. But now let's deal with sine. You can see the angle that we are dealing with here is theta, sine theta. Now you know that sine is given by opposite over hypotenuse, and the opposite side to theta is y. The hypotenuse is r, so that is going to be sine theta. And then when we talk about cos theta, the cos is given by adjacent over hypotenuse. The adjacent is x, the hypotenuse is still r. Okay, so don't forget about these two guys, they are very vital. Let's come back here. So what I want to do is that I want to make this side to be a 1. So I'll divide everything by r squared. Now because we have got x squared on top, down we have r squared, I can as well say this is x over r, and then I put the square outside. And then y over r also, I can as well say this is y over r, and then I square outside. And then r squared over r squared, that is a 1. But where there is x over r, can you see that x over r is cos theta? So I'm going to substitute cos theta there. So it becomes cos theta and then it will be squared. Where there is y over r, can you see y over r is sine theta? So I'm going to put sine theta there, and then that will be squared, and this is going to be equal to 1. Now cos theta squared is the same as cos squared theta. Sin theta squared is the same as sin squared theta. So I'll just start with the sin. So this gives us sin squared theta, and then plus cos squared theta. This is equal to 1. This is the basic identity from where all other identities will come from. So if you know this identity, then you basically know all identities. Okay. Is there any question here? Are we okay? Are we okay? You can simply react if you don't want to open your mic, if you are good. Okay. So now that we know this identity, we as well know that tan theta, how do you find tan? Tan theta is given by sin theta over cos theta. Okay? This is an identity. So what happens if I get tan, I square it, it becomes tan squared theta. It means that sin is also going to be squared, cos will also be squared. So tan squared theta therefore is sin squared theta over cos squared theta, right? But remember from the previous identity that we are from deriving, we said that sin squared theta plus cos squared theta is equal to 1. So what I'll do is that I want to make sin squared theta is subject to the formula. So it becomes sin squared theta is equal to 1 minus cos squared theta. And then I'm going to come here. Where there is sin squared theta, I'm going to put 1 minus cos squared theta. Remember, everything is over cos squared theta. And then this is going to give us 1 minus cos squared theta over cos squared theta. I can as well split the numerator. So it becomes 1 over cos squared theta minus cos squared theta over, the denominator will be split to both numerators. Remember, this is tan squared theta. Therefore, end up giving us tan squared theta being equal to 1 over cos. Now, we did mention that the opposite for sin, is 1 over sec. The opposite for cos is 1 over, sorry, this is cosec. So the opposite for sin looks like cos. So it is cosec CSC, or you just see cosec COSEC. For cos is sec. So from here, since we've been given 1 over cos, 1 over cos is sec, just like 1 over sec is cos. So this is going to be, because it is cos squared, this is going to be sec squared theta minus cos over cos, that's a 1. So this is another identity that you want to be aware of. Tan squared theta is equal to sec squared theta minus 1. Let me just derive its opposite or its counterpart. We see how it comes about. Who knows the reciprocal for tan? What is the reciprocal for tan? Now, the opposite for tan is cot. And cot theta, since tan is sin over cos, then cot is going to be cos over sin. So if I square cot, I also square cos, I also square sin. So this ends up giving us, where there is cos, I can as well put 1 minus sin squared theta. Remember from the first identity, we just made cos a subject the formula. And then down we have got sin squared theta. And then I'll split the denominator to both numerators. And that gives us 1 over sin squared theta minus sin squared theta over sin squared theta. So this gives us cot squared theta being equal to 1 over sin. Remember, this opposite for sin is cosec. So this is going to be cosec, but because sin is squared, so that will be cosec squared theta minus 1. This is another identity that you want to pay attention to. Okay, very important one. Don't forget. Okay, we have done enough of these ones. Let's go to what we call double angles. What are some equations that we deal with when it comes to double angles or multiple angles? So the first one that we need to know, let's start with sin. When you have got sin A plus B, you need to know that this is going to be equal to, you first get sin, you get the first angle, in this case it's A, you change to cos, you get the second angle which is B. If it is a plus, still put a plus here. And then now get sin again. Now don't get the first angle, get first the second angle. And then get cos. Now you get the first angle. This is how you deal with this one. So if it was in A minus B, just where there is a plus here, what you do is you put a minus, just that. Now imagine where there is B, we actually add A. Imagine where there is B, we add A. So at every point where there is B, we're going to put A. At every point where there is B, we're going to put A. And you know that A plus A is going to be 2A. Therefore, sine 2A is going to be equal to sine A cos A plus sine A cos A. But remember, sine A cos A plus sine A cos A, you are adding the same thing. X plus x is 2x. So sine A cos A plus sine A cos A is 2 sine A cos A. I don't want you to forget this identity. Never you forget this identity. If you remember, when you're talking about projectile motion, when we are deriving one equation for projectile motion, we use this identity. Okay? So here, don't forget that. Now, I want you to imagine this. Imagine we half the angle. We make the angle as half. What then is going to happen? What do we mean by saying we half the angle? So if we get this angle here, instead of it being 2, we make it a 1. Even this angle here, instead of it being a 1A, it will become half A. That is what you want to understand about this. Okay? So if you half the angle, you are going to have everything. But let me not talk about it here. What I just want you to understand now is that sine 2A is the same as 2 sine A cos A. Let's go to the third equation or identity. And that is for cos. When you have got cosine of A, let's say plus B, this is going to give you cosine of A. You get first the first angle, but for cos, you write again cos, don't change to sine, and then get the second angle. But you change the sign. If it was a plus, it becomes a minus. If it was a minus, it becomes a plus. So it becomes minus. Now get sine, you get the first angle. Again sine, you get the second angle. So this is a difference for cos, all right? You get first cos, the first angle and the second angle. You change the sign, you go to sine, the first angle and the second angle. Now imagine if where there is B, we add A. So at every point where there is B, we are going to put A. So what does that become? A plus A, you know that is 2A. So this is going to become cos 2A being equal to, so we're going to have cos A, and then minus sin A, sin A. So this is going to give us cos 2A being equal to cos A, that is cos squared A. Sin A is sin squared A. So this is the first identity you need to know here, that cos 2A is the same as cos squared A minus sin squared A. But we can derive two more identities from this one. Remember that cos squared A plus sin squared A is equal to a 1. So if I take sin the other side, cos squared A will remain 1 minus sin squared A. So this will become cos 2A is equal to, where there is cos squared A, remember if I take sin the other side, it will become 1 minus sin squared. So where there's cos squared A, I'll put 1 minus sin squared A. But remember we have got another minus sin squared A. So this gives us cos 2A being equal to 1 minus sin A squared minus sin A squared. That is going to be, just add the same thing like sin A. That is going to be 2 sin squared A. Never you forget this identity. Never forget it. But had we substituted, remember the same, we could have made sin the subject to the formula. So it would have become 1 minus cos squared. So I would have said cos 2A is equal to cos squared A minus. But where there is sin squared A, if I make sin squared A solve the formula, that will become 1 minus cos squared A. And so this will end up giving us cos 2A being equal to, if I distribute this negative, it will be negative 1, and negative times negative cos, that will be positive cos. So that positive cos will add with the positive cos, it becomes 2 cos squared A, okay? And then remember a 1 is negative minus 1. So these are the three identities that you need to know about cos 2A. You can see we I'm showing you this because I know the badness of mastering. I did this maths some years ago, but then I will explain this to you without br- using a book for you. That is to tell you that you can know this by heart. Okay? You don't need a book for you to remember. So please know this by heart. It will save you a lot than you trying to master the final equation. Okay. Now that you know these guys, I want to tell you these are called what? Double angles. Okay? These are called double angles. How about what we call half angles? How do you handle them? So let's deal with half angles. It is the same concept. You see others writing half angle formulae because they are formulas and there is a certain way in which you apply them. Trust me, if you understand this, there's no this one I can assure you shall never fail a question on trig. And this is coming in test 2. It is definitely coming in the exam. Not if you don't want it to be there in the exam, then you are not in university. Okay. So when you are deriving the half angle formulae, we are basically using these two, the ones I've written down, cos 2a. So I'm saying cos 2a is equal to 1 minus 2 sine squared a. Okay? And then the other guy is the same two guys we derived from cos. We also found that cos 2a is 2 cos squared a minus 1. I want you to follow this well because it will really be interesting. Look at how we are getting the angles. What I want to do is that I want to make 2 sin squared a subject to the formula. So what am I going to do? I'm going to take the 2 sin the other side and then the cos 2a the other side. So it becomes 2 sin squared a is equal to 1 minus the cos 2a goes the other side, cos 2a. Please never you confuse cos 2a. It is not the same as cos squared a. Make sure that you pay attention to that. They are never the same. Totally different things. Okay, and then what are we going to do next? What I'm going to do is that, look at this. If this angle is a double angle, you can see that's a double angle. But then we are dealing with what? Half angles. What are we going to do? Where there is A, we are going to substitute half A. At every point where there is A, we are going to put half of A. So therefore, this will become 2 sin squared. So because this is A, to become A over 2. And then minus is equal to 1 minus cos. Because this is 2A, the half of A, remember, is half. So that half times 2, it will just become A. So if I half the angle 2A, if I find the half of 2A, I should also find the half of A, which is A over 2. At this point, I'm going to divide both sides by 2, so it becomes sine squared A over 2 is equal to 1 minus cos A. Everything is going to be over 2. I want to do away with a square, so therefore sine of A over 2 is going to be the square root of 1 minus cos A divided by 2. So this is the formula that you need to know, that sine A over 2 is actually equal to the square root of 1 minus cos 2A over 2. Very easy formula, as you can see. That is the same thing that we're going to do with this side. I want to make two. Yes, please, precious. Okay, as you can, this angle is a 2A. So if I find the half of 2A to give me A, this angle is A. If I find the half of A, I'll find A over 2. Okay. Now let's go the other side. I want to make 2 cos squared A sub the formula. So I'll just get 1 and take it the other side. So it will become 2 cos squared A is equal to the 1. If it goes to the other side, it become positive 1. And then it will find cos 2A. And then also half the angle here. So it will become 2 cos squared. Where there is A, put A over 2. We have halved the angle. And that will be equal to 1 plus cos. Where there is 2A, put A because that's half of the angle. Divide both sides by 2. That will become cos squared A over 2 is equal to 1 plus cos A everything over 2. And then I'll square root for to just remain with cos. So therefore cos A over 2 is going to be the square root of 1 plus cos of A divided by 2. Is there anyone who is lost? Is there anyone who is lost? Please, please never feel shy. Remember, these things are coming in the exam, right? And your test too. So don't feel shy. Okay? Okay. So let's make the life derivation, the last derivation. Then we do exam questions. The last derivation is about tan. So we are talking about the tangent of A plus B. What does this give us? Now the tangent of A plus B, you know that tan is actually equal to what? So tan is equal to sine of A. It's basically sine over cos, right? But because it's A plus B, so that's why I'm also putting like the cos A plus B. So this. But remember, sine A plus B is sine. You get the first angle A, and then you get cos the second angle B. Remember, you don't change the sign, and then you get sine. Now get the second angle B, and then you get cos. You get the first angle, which is A, and then you divide. And then for cos, remember for cos we said that to get cos, get a first angle. Again, cos, get a second angle, but you change the sign. Sin, get a first angle, and then sin, get a second angle. I hope that is not hard. At this point, what you do is very, very interesting. So what I'll do is this. Please look at what I'm doing. On top, I'm going to write the sine A cos B the same way it is. Okay. And then there is also the sine. Remember, there is a plus. There is sine B cos A. I've left a comma space down. That will be also the same I'll do down. All right, cos A, okay, cos B, but there's a minus. And then I'll still write sine A, sine B, okay? So there. And then what do we do next? What you are going to do next is that now you start dividing. This term that is here is the term that you are going to divide with. Please don't get confused, really. There's nothing complicated. Okay, just make sure that you follow through what I am doing. So what have I said? The first term that I've pointed at there is the one you are going to get and divide everything. Okay, so I'll divide everything. I'll divide this term by cos A, cos B. I'll also divide this term by cos A, cos B. I'll divide this term by cos A, cos B. I'll divide this term by cos A, cos B. So I'm basically getting the thing that is at the bottom of the denominator, isn't it? Okay, so what are we saying? Divide everything by that guy. And see the interesting thing that is going to happen. Really, no magic. Where can I even write? I'll put it here. Therefore, tan A plus B is going to be equal to, can you see that cos B will cancel with cos B? Can you see that? What else? Cos A will cancel with cos A. Can you see that here this will cancel with this will cancel with this? And then here, can you see that on top we have got sin B, down we have got, okay, so for this side nothing. So on top we have just remained with sin A over cos B. I mean sin A over cos A, and sin A over cos A, that is tan A. Okay, and then the second one went on top with sin B, down with cos B, and sin over cos, that is still tan, but the angle now is B, and then everything over the first term, everything cancelled out, so that was a 1 minus. For the second one, we have got sin A over cos A, that is tan A, and then we also have sin B over cos B, that is tan B. So this is the identity that you use for tan A plus B. So the only thing is, if the sign changes, it becomes tan A minus B. Just come here, put a minus, and then here put a plus. Those are the only two things that changes if you change the sign there. So it is actually the same identity that we want to use. Say where there is A, if we substituted with B. Okay, so if where there, let's say where there is B, we put A. If here where there is B, we put A. It means that at every point where there is B, we put A. At every point where there is B, we put A. So, and we know that A plus A is tan 2A. So that would have become tan 2A is equal to tan A plus tan A over over what? 1 minus tan A tan A. And this would have given us tan 2A being equal to tan A plus tan A. You know that is what? 2 tan A. And then in the denominator, we are going to have 1 minus tan A times tan A, that is tan squared A. So this is the formula we use for a double angle for tan. You can see how easy these guys are, right? So that's the double angle for tan. Okay, so with the teaching I'm done. Let's do exam questions. First, is there any question? Are we good? Are we good so far? Okay, let's start with this one. You will be surprised to find these questions. Prove the identity 1 minus cos 2a plus sin 2a over 1 plus cos 2a plus sin 2a is equal to tan a. So this is the right side, the right hand side. This is the left hand side. When you're proving identities, you want to start with the side that is more complicated to go to the side that is more simple. So which one do you think is the most complicated side here, left or right? Which one? Precious, you're saying something? The left. Very good. So we're going to get the left hand side and show that is equal to tan A. So that will become 1 minus. Now where there is cos 2A, remember the identities we are substituting? The same ones we've derived. And remember that cos 2A, there are three possible identities that we could have used for cos 2A. And whatsoever that we pick will be up to us. So because I can see, okay, it's just up to you. Remember cos 2A is cos squared A minus sin squared A and some other main identities. Let me express everything in terms of sin. What I mean is that I want to use this identity here, this one. Where there is cos 2A, I'll put 1 minus 2 sin squared A. So that will become 1 minus. So this is 1 minus. Where there is cos 2A, please don't forget to put a bracket there. I'll put 1 minus 2 sin squared A. And then plus. Now where there is sin 2A, remember sin 2A is 2 sin A cos A. Everything over 1 plus. Where there is cos 2A, I'll put 1 minus 2 sin squared A. Okay. And then plus where there is sin 2A, I'll put 2 sin A cos A. And then this will become, I'll distribute the minus. So minus times 1, it will be minus 1, isn't it? And so that will be 1 minus 1, and that will cancel out, right? And then the 1 times negative 2, it will become positive 2 sin squared A. And then plus 2 sin A cos A, right? Remember the 1 has cancelled out, isn't it? And then down over, we are going to have 1 plus 1, that is going to be a 2. Then we are going to have minus 2 sin squared A, and then plus 2 sin A cos A. So this is where we're going to reach here. Are we going together? Are we going together? So when it comes to identities, you don't force things. Okay, that is one thing you need to know. You don't force things. If you are doing what is wrong, it will just refuse itself without you forcing it. So from here now you should be thinking about what next can I do? Like what next can I do? Okay. So for me here, because it seems a bit of complicated, what am I going to do? Please just don't y- sometimes you jam, okay, like you don't know where to go next. Don't give up. Just see what you can do. So on top, can you see that we have got 2 sin and 2 sin? So I'm going to factorize out a 2 sin a, and then here there was sin squared, so 1 sin a will remain. And then here we had 2 sin a cos a, so only cos a is going to remain like that. And then it down, because I am a person that doesn't love, that will not give up, even if it looks a bit hard. What am I going to do? I'm going to get these two terms here. I'm going to factorize out 2, because mathematically I know I am factorizing out a 2. I know. So I'll factorize out a 2. I'll remain with 1 minus sin squared theta. Some of you with mathematical eyes, you have seen already why I was factorizing out a 2. And then I'll continue. I'll come this side. I'll write 2 sine A, and then sine A plus cos A. Those with mathematical eyes, what can you see about 1 minus sin squared theta? Why did I change to theta? This is A. What can you see about that? No one has mathematical eyes. So 1 minus sin squared A is the same as cos squared A. So I've substituted where there's 1 minus sin squared A with cos squared A. And then remember I've got plus 2 sin A cos A. And this will give us 2 sin A, open brackets, sin A plus cos A. In the denominator, you can see we have got 2, 2. I'm going to factorize out that 2. And then cos is common. I'll factorize out cos A. So we remain with 1 cos. And then the other side will also remain with a sin, because we factorize out a cos. Can you see that this and this is the same? And 2 and 2 will cancel out. We remain with sine A over cos A. Anyone who can tell me what is sine A over cos A? Anyone? Yes, Lynette. Yes, you can open your mic. Tan A, very good. Okay, tan A. So can you see that we have shown at the end, just write hence, because they said prove, hence proven. Okay, so that is it. Let's go to this one. They have said that given that sin theta is negative 3 over 5 and tan alpha is 3 over 4, theta is a third quadrant angle and alpha is acute. We want to find these terms down here. So what you do is first write your Cartesian plane for this one. You are applying you are applying what we did in the first class with what we have done today. So remember they've told us that theta is in the third quadrant. The meaning of that is that theta is here. Now if you remember, I said that every time you're dealing with trig, you're always interested with the angle related to the x-axis. If you are in the first quadrant, the angle related to the x-axis is this one. Second quadrant, the angle related to the x-axis is this one. Third quadrant, angle related to the x is this one. Fourth quadrant, angle related to the x is this one. You are always interested in the angle related to the x, not to the y. This is the y-axis, the one which goes up and down. You are not interested in those angles. Okay? Because we are interested in that, so meaning that the angle that of our interest, which we are calling as theta, is this angle. Not this one. This angle is related to the y. We always want what is related to the x. So I'll form a triangle. I'll take it back like this. And from what we've been told that sin theta is negative 3 over 5. But you know that sin is opposite of hypotenuse. So if the 3 is on top, it means that that's the opposite. And then the hypotenuse is 5. But where is the negative coming from? You can see that this is along the negative y-axis. So the 3 is actually negative. 5, the hypotenuse can never be negative. It's always positive. So if you have got a negative number, it's always one of the two sides. Okay? Now that we know the sides, we need to find this missing side here. How do you find that missing side? You basically get the hypotenuse, you square it, you get the other side, you square it, and then you subtract them, you square root. So it's 5 squared minus negative 3 squared, and then you square root. Very easy. 5 squared is 25, 3 squared is 9. You square, if you add it to give you 16. The square root of 16 is a 4. So this is going to be a 4. But remember, this is the negative x-axis. It's going to actually be a negative 4. We've been told that alpha is acute. Acute angles are in the first quadrant. If you remember from the previous class, that's why connections are very important, all right? And math, you need to make sure that the topic you start from the beginning because you don't want to be mixing components. So someone who has not attended this class today, the time we'll be dealing, because the last class we're having on this topic is on equations. If they join a class on equations, they will not understand anything. Believe me, they will not. Because in equations, we'll be using special angles also. There. So this is the angle alpha we are talking about. We've been told that tan alpha is 3 over 4, but we know that tan is the opposite over adjacent. So 3 is the opposite, the adjacent is 4. So if you want to find the missing angle, that's the hypotenuse. Missing angle is found by what? This is the hypotenuse. It is 3 squared plus 4 squared, and then you square root. So 3 is 9. If you square it, 4 is 16. If you add those, it will give you 25. The square root of 25 is a 5. So this is going to be a 5. Now we can answer our questions. The question is find sin alpha, cos theta, and cos alpha. So starting with sin alpha, you know that sin is given by opposite over hypotenuse. So if you go to the angle alpha, opposite is a 3, hypotenuse is 5. And then we go to cos theta. Cos theta. Theta is this angle. You know that cos is given by adjacent over hypotenuse. Adjacent is negative 4. Hypotenuse is a 5. And then go to cos alpha. You know that cosine of alpha is given by adjacent. Alpha is here 4. Hypotenuse is 5. So that is going to be 4 over 5. As easy as that. And then for the second one, find sin theta plus alpha. So sin theta plus alpha, the first thing you need to know is how to expand this. Remember we said you first get sin, you get the first angle, and then you get cos, you get the second angle. We said that you always maintain a plus. Now get sin, get the second angle, and then get cos, get the first angle. So now we substitute where there is sin theta. Remember sin theta we've been given on top, that's negative 3 over 5. This is times alpha here, cos alpha is 4 over 5. Okay? And then plus sin alpha, it's there, it's 3 over 5. And then times cos alpha, cos theta, that's negative 4 over 5. And this is going to give us negative 3 times 4 is negative 12 over 5. 3 times negative 4, that is still negative. So let me just remove the positive here because it will end up being negative 12 over Not 5, but a 25. 5 times 5 is a 25. Since the denominator is the same, simply add the numbers on top. Negative 12 minus 12. That's negative 24 over 25. So this is the answer for this one. You can see how interesting they are. And then for the last one, want to find tan. But remember what we said by tan theta minus alpha. Let me write it on a better position. So for tan theta minus alpha, this is going to be equal to, remember we said you first get tan, get the first angle which is theta. If on top there was a minus, you maintain the minus. And then now get tan, the second angle which is alpha. Remember we said you divide, you put 1 here. If there was a minus, down here you are going to put a plus. And then you write tan, the first angle, theta, and then again tan, the second angle which is alpha. So now just come and substitute. So what is tan theta? Tan theta. So just come here where there is theta. Tan is given by adjacent over hypotenuse. Adjacent is negative 4. The hypotenuse is, sorry, tan is opposite over adjacent. So katoa. Opposite is negative 3, adjacent is negative 4. So that is basically 3 over 4. And then minus tan alpha. Tan alpha is what we've already been given there, which is 3 over 4. And then down we are going to have 1 minus tan alpha, that is 3 over 4 multiplied by also 3 over 4. But you know that 3 over 4 minus 3 over 4 is 0. 0 over anything, the answer is 0. So basically the answer here is going to be 0. Very simple question, isn't it? Have I lost anyone? Lynette, your hand is up. Is that your question? Okay. You can just drop the hand. Regina, that's a question? Faith, that's a question? Hmm. Okay, so if you look, yes, they're supposed to be negative, but you know negative numbers cancel. So tan theta is opposite over adjacent. Opposite is negative 3. Adjacent is negative 4 and negative over negative. So the signs cancel out. Okay, so that is it with this question. Let's look at this. So you people, I'm answering all these questions for you. You should be so powerful on this topic because totally I've not left out not a single concept. I could have just thought and forgotten about it, but I'm doing questions because repetition, they will just repeat. So if you, after this, in case you forget, solve the same questions. If you have not registered with us, you can just screenshot these questions so that you'll be practicing on them. Otherwise, if you don't, you'll not access them again. Okay, so you'll be practicing. Try to make sure if alone you can solve them again. Right? Use the resultant that cosec x minus cot x is equal to tan of half x. Show that tan 15 is equal to 2 minus square root of k. I love this. Okay, so we want to use the resultant that cosec x minus cot x is equal to tan of half x. Well, the goodness is that for this guy, state the value of k. Like you've already been given really what you are dealing with. Okay, you've already been given here. So what do you want to do at this point? They've already given you what to use. Like this is the goodness. They've already given you what to use. So I can start with this side. I'll say tan of 1 over 2x is going to be equal to cosec x minus cot x. The reason as to why we deal with special angles is that, you know, special angles. Look at the angle that you've been given, 15. We have got three special angles, 45, 30, and 60. The other special angles are multiples of 90, like 0, 90, 180, 270, 60, and you continue adding 90 to each number. Those are all special angles. So look at this. This is a 2. So the question is, what number can I divide by 2? And it's a special angle, and it should give me a 15. Oh, tell me. Who will be bored to tell me? No one. No one. What number will I divide? Yes, Lynette. 15. It's because you are eating. That's why I'm getting confused. Okay, very good. It's a 30. So we're going to say that let x be equal to 30. And you know 30 is a special angle. You every time they're asking you about finding values, just make sure that you use special angles. So this is going to become tan, where there is x, I'll put 30. And you know that half times 30 is 15. So that will become tan 15. And that is going to be equal to cosec, where there is x, I'll put 30, minus cot, where there is x, I'll put 30. You see? So that's tan 15 and this is tan 15. So all we do is just work out the terms. Now you know that cosec is a reciprocal for sine. So this is 1 over sine 30. And you know that cot is reciprocal for tan. So this is 1 over tan 30. From the first class that we had, you should remember special angles. Sine of 30 degrees is 1 over 2. And then tangent of 30, so the angles that we use for these special angles for 30, we use this triangle. Please revisit the class if you're not good. You need to know those. This is a 60, this is a 30, this is a 2, this is a 1, this is root 3. So sine 30 is opposite of hypotenuse, okay? Opposite of hypotenuse. And then when it comes to tan 30 is going to be, remember tan is opposite of adjacent, so opposite is 1. Adjacent is root 3. So therefore this guy is going to become 1 over, where there is sine 30, we'll put 1 over 2. Then minus 1 over, where there is tan 30, we'll put 1 over root 3. Now, every time you have got 1 over 1 over, this is the same as 1 divided by 1 over 2, 1 divided by 1 over 2, and then it changes to 1 times 2 over 1. You know what happens. So basically, you just get a denominator. So this is going to end up giving us 2 minus root 3. And that's what they gave you. And they've just said state the value of k. Therefore, k is equal to 3. Direct and easy. Is that okay? Okay. Now this one I've already derived for you. Prove that tan x minus pi over 4 is tan x minus 1 over tan x plus 1. I've already derived for you this one. I don't know if you want me to do it again. So basically, you know that tan x minus pi over 4. Remember what we said about special for tan? We said that this will become tan, get the first angle, which is x. If it is minus, always put that minus is still there. And then tan the second angle, write it, that's pi over 4. We said you divide, you write first one, you change the sign, it becomes positive. You get tan, get the first angle, which is x. Again, get tan, get the second angle, which is pi over 4. Now, pi over 4 is 45 degrees. We talked about that in the previous class. How do you convert to degrees? Simply multiply by 180 over pi, and that is going to give you 45. And tan of 45, the triangle that we use for the special angle 45 is isosceles, where this is 45, you get this as 1, this is 1, and this is square root of 2. Tan of 45 is a 1. Okay, so that will become tan x minus, where there's tan 45 or pi over 4, that will be a 1, then divided by 1 plus tan x, where there's tan 45, that is still a 1. We can as well write this because you know that addition is commutative, so this will be tan x minus 1 over, I can start with tan x plus 1. Hence, proven. Addition is commutative. Are we okay? Are we good? Okay. So this one, please screenshot it, answer it. You can send to me if you want to confirm. This one is basically you are trying, just simplify this. After you simplify it, it will give you a number, a constant, and that will be the value for k. That is the same one with this one. Just simplify it. Anyway, choose one. I do one for you so that you mwike salanda tawe. Which one? Is it this one or this one? Which one should I answer? I've given you 2 seconds to choose. If you don't choose, I'll leave both. One, two. Yes, yes, Natasha. With M. Precious, which one do you want? Yes, Precious, your hand is up. Okay, we'll choose the one Natasha's chosen. Find the integer M. So start with tan squared theta. So I'll just put tan there, tan squared theta over, what is 1 plus tan? Remember the identities. I don't want to derive again. Remember for tan, can you see that tan squared theta is x squared theta minus 1? Okay, so that's what you want to use. But anyway, this is 1 plus tan squared theta. So I can substitute where there is tan. Which root should I take? Okay, let me take no roots. But instead, let me make it way easier. Let me make this as a single fraction. Get what is on top of the first fraction, multiply with what is down in the second fraction. So tan theta times 1 plus cot theta, that is going to be tan squared theta plus tan squared theta cot squared theta. Get what is on top of the first, second fraction, multiply with what is down the first. That is going to be cot squared theta. Yes, precious. How do you add single fractions? Do you know how we add single fractions? So you can relate now? Okay. And then after, so what you use the butterfly method. So multiply this, and then multiply this, and then multiply the two denominators. That's butterfly. Oh, yeah. So now multiply the two denominators. So that will be 1 times 1, that is a 1. 1 times cot, that is going to be cot squared theta. Tan times 1, that is going to be tan squared theta. Tan theta times cot theta is going to be tan squared theta cot squared theta. Now let's add what's on top. Hope you can see the way they are. But then remember, tan and cot are reciprocals. What happens when you multiply a number by its reciprocal? You get a 1. So this is a 1. This is a 1. And this is a 1. So we're going to have tan squared theta plus 1 plus cot squared theta, again plus 1, then divided by 1 plus cot squared theta plus tan squared theta plus 1. So 1 plus 1 there, that is a 2, then plus tan squared theta plus cot squared theta. And then down you can see we have got 1 plus 1, that is a 2, plus tan squared theta plus cot squared theta. Can you see that this is basically the same thing? So that will give you a 1. So that is a value for m. Is that okay? Okay. So you can screenshot these two. You can practice. Even this one, given that sine A is 4 over 5, cos B is 12 over 13, A is obtuse, B is acute. Find tan A plus B. You can try that one also. Ah, I love this one. Let me answer for you this one. I know it too. Should I answer? Or you can answer? I remember they brought this one, should be in one of the tests. I don't know if it's a test or a quiz. Yeah, these are the questions. Now here you can see they've given arc. Arc is inverse. So it's like this. When you have when they tell you that sin 30 is 1 over 2. If you take sin the other side, you know it becomes sin inverse. So therefore sin inverse of 1 over 2 will give you 30. Okay? But saying sin inverse is the same as saying arc sin of 1 over 2. That will give you 30. Basically, that is what this is telling us. Why did I even include it? Anyway, so we are talking about what is the sine inverse of root 3 over 2. So we'll go to the special angles. So this is a 1, this is a 2, this is a root 3. You see why I am telling you need to know the special angles? So sine is given by opposite of hypotenuse. So if you look at here, sine of 60 is going to be opposite. Opposite is root 3 over 2. So sine of 60 is square root of 3 over 2. So if we find the sine inverse of root 3 over 2, or arc sine of root 3 over 2, it is going to give us 60 degrees. So therefore this we are going to say cos, where there is arc sine root 3 over 2, we are going to put 60 degrees there. And that should be equal to x plus square root of 2. But cos 60, come back here. Cos is given by adjacent over hypotenuse. Cos 60 is 1 over 2. So that gives us 1 over 2 is equal to x plus square root of 2. To find x, take root 2 the other side. So x is going to be 1 over 2 minus root 2. This is over 1. So therefore x is going to be 1 minus 2 root 2 over 2. Simple. So that is how you find this one. Okay. Yeah, and I want you to do this one. Okay. Please, this one, make sure that you try it out. Show that cos a minus b minus cos a plus b is 2 sin a sin b. Hence, show that cos 2x is equal minus cos 4x is equal to 2 sin 3x sin 2x. You can end here. Just these two. The last one about find all the solutions, we'll do it in the next class for equations. Okay, so that is it. Watch out for next part, and that will only be for the registered students.